Hello everyone, I am Ma Zhenglu. I am from Sichuan Vocational College of Chemical Technology. Today, we're going to learn about the strength of polymers. In the many applications of polymer materials, the use of polymers as structural materials is the most common and important application. In many fields, polymer materials have become substitutes for metals, wood, ceramics, glass, and other materials. This is because, in addition to their advantages such as ease of manufacturing and processing, lightweight, and chemical corrosion resistance, they also have relatively high mechanical strength and toughness. For example, theoretically, the maximum tensile strength of polyethylene is about 1.9 times 10 to the fourth power megapascals, which is tens of times stronger than steel wire. In the laboratory, the highest actual strength of polyamide fibers in liquid nitrogen has been measured at 2.3 times 10 to the third power megapascals. The strength of materials mainly includes three aspects: tensile strength, flexural strength, and impact strength. First, we need to understand the commonly encountered tensile strength in materials. Tensile strength, also known as tensile strength, is a measure of a material's ability to resist fracture when subjected to tensile forces. It is of significant importance in engineering design and material selection. Specifically, it refers to the maximum mechanical tensile stress that a material can withstand during a tensile test. If this stress is exceeded, the material will fail. That is, the material's ability to absorb force will decrease until the material sample ultimately fractures. The calculation of tensile strength is the ratio of the maximum load P applied to the sample before fracture to the cross-sectional area of the sample. It is expressed as the ratio of force to the area subjected to the force. The unit is Pascal or megapascal. Materials with high tensile strength can withstand greater tensile forces without fracturing. This makes them suitable for applications that involve heavy or dynamic loads. The determination of tensile strength is typically performed through tensile testing. In the test, the sample is fixed in a tensile testing machine. Then tensile force is gradually applied until the sample fractures. By measuring the tensile force and corresponding elongation, we can obtain important parameters such as tensile strength, yield strength, and elongation. Tensile strength is influenced by various factors, including the material's composition, microstructure, processing techniques, and temperature. In practical applications, tensile strength is one of the key indicators for evaluating the suitability of materials. For example, in fields such as bridge construction, automobile manufacturing, and aerospace, materials are required to have high tensile strength to ensure the safety and reliability of structures. In conclusion, tensile strength plays an important role in our material selection. I hope everyone can focus on mastering it. Bending strength, also known as flexural strength or resistance to bending, is an important indicator of a material's ability to resist failure when subjected to bending loads. It refers to the ratio of the maximum bending moment a material can withstand to the moment of inertia of its cross-section during a bending test. It is usually expressed in megapascals. Bending strength testing is typically conducted through 3-point bending or 4-point bending tests. In these tests, the standard specimen is placed on two support points. A concentrated load is then applied above the specimen. As the load increases, the specimen will bend until it ultimately fractures. Bending strength can be calculated by measuring the maximum load applied and the geometric properties of the specimen. Bending strength is influenced by various factors. These include the type of material, microstructure, processing methods, temperature, and loading rate. For example, the bending strength of polymer materials may be affected by molecular weight distribution and additives. In the material design process, It is crucial to consider the maximum bending stress the component may encounter during actual use. This ensures that the selected materials and components meet the safety requirements for bending strength. For example, structures like bridges, airplane wings, and building beams need sufficient bending strength to withstand the expected loads. In summary, bending strength is a key concept in engineering design and materials science. It is critical for ensuring the safety and functionality of structures. Impact strength, also known as resistance to impact, is a measure of a material's ability to resist failure when subjected to a sudden load over a short period of time. It is an indicator of a material's toughness. This performance metric is crucial for designing and evaluating engineering structures that may encounter impacts, drops, or other forms of rapid dynamic loads. There are many testing methods for impact strength. The most widely used include the pendulum impact test, drop weight impact test, and high-speed tensile testing. Tests are typically conducted using cantilever and simply supported beam testers. A cantilever sample fractures when struck by a pendulum falling from a certain height. The energy required to break the sample is measured to assess its impact toughness. The results are typically expressed in joules per square inch or joules per square meter, which is known as the impact energy. As shown, this is a simple beam impact tester. This is a cantilever beam impact tester. The level of impact strength is also influenced by various factors. These include the type of material, microstructure, temperature, and loading rate. For example, the impact strength of metals at low temperatures is usually lower than at room temperature, because the material becomes more brittle and rigid. In addition, some materials, such as polymer composites, may exhibit different impact strength behavior due to the complexity of their internal structure compared to traditional metallic materials. The calculation of impact strength is done by dividing the energy consumed in the impact process by the effective cross-sectional area of the sample. This ensures the safety and reliability of the product or structure when faced with unexpected impacts. For example, the automotive industry pays special attention to the impact absorption capacity of materials when designing vehicle bodies and bumpers, in order to reduce passenger injuries in collision accidents. Similarly, material selection in the aerospace industry also rigorously considers the impact strength in extreme environments to ensure the integrity of the aircraft and the safety of the crew. Therefore, impact strength is a key parameter in evaluating a material's performance under dynamic loading. It is directly related to the material's range of applications, as well as the safety and durability of the final product. Therefore, when selecting materials and designing structures, impact strength must be fully considered as a performance indicator. In this course, we primarily discussed the strength of materials. This mainly involves tensile strength, bending strength, and impact strength. Material strength is a very important parameter, as it directly affects the material's quality and safety. I hope you can become familiar with and master its calculation methods. That's all for today's lesson. Thank you for listening. See you next time.